Okay, part 2 of dplyr. Here to talk to you about chaining, or also known as piping, maybe more commonly called piping. So now this is a fun thing that's going to require a little bit of concentration, and a little bit of kind of a different way of approaching how we code in R, but there's a lot of really nice benefits to this. And I end up using this more and more as time goes on. So what am I talking about? Well, there are often a series of steps that we need to perform on a data frame. Rather than spending a bunch of time setting up code, piping lets you think through the steps in succession as you would speak it or as it would be intuitively to you. So first I have a data frame, then I need to filter by these observations and select these observations based on this conditional. Then I need to group by this thing, and then I need to summarize it this way, or what have you. There's lots of different ways that that we think through analyses. Now in R, things can become, there's these nested functions or functions nested within functions, and that can be trying the quest for most coders, which would be to perform there's a bit of, can I do this quicker, more efficiently, or with less lines of code? And so nesting, can be a thing that takes some time and just additional bandwidth to kind of pick through the pieces and figure out which piece is piece A that's nested within piece B, which nested within piece C, or whatever, right? So piping allows you to kind of disentangle all that and just go successively from one thing to the next. Okay. So, and you probably don't know what the heck I'm talking about, which is fine. You'll see this in just a second in demonstration. Sometimes a lot of this stuff is just hard to articulate, and so just seeing it in the process makes things a lot clearer. So piping uses this weird symbol. It's a, don't look at the quotes here, but it's a percent sign with a greater than sign and a percent sign, okay? And so here's a simple example. Data frame, and we're gonna pass this function onto the data frame, which is filter, and filter is city greater than 25. So city miles per hour greater than 25. And what happens when we do that? Well, we get this, this is basically the same as this filter function. This is what we just had talked about in the first part of the class. So filter applied this function filter to the data frame, and the condition is that return all observations where city is greater than 25. City mile per gallon is greater than 25. Okay. Here it's the exact same thing. If we run this, it's going to give us the exact same thing as before. This earlier one, which is, it's the exact same code in terms of what it generates and what it does, but how you ask for that output is different. And here, again, it might be more intuitive in terms of how you think through it. Imagine if you're like actually dictating code, dictating the syntax here. You could say, take the data frame and then filter the data frame where observations were blah, 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 right? So in this case, city miles per gallon is greater than 25. So here, again, these two lines of code are the same. Now let's take another example, miles per gallon. And then we're going to select columns 1 through 4, right? So we run this, and here we're just showing the first 4 columns in the MPG data set. That is synonymous with saying select, apply that function to MPG, and then give us 1 through 4. Okay, so same. Okay, well, what's the big deal? Steve, all you're doing this week is showing us how we already know how to do things, but making it more like just functional redundancy. It's why don't, this I already know how to do that. This the old-fashioned way. Why are you showing me a new way? Okay, it's because the world isn't that simple, and lots of times we have more complicated problems or issues or questions, right? So take an example. What models have an average city mile per gallon greater than 18? Okay. Here's our MPG data set. It's a tibble, right? We've seen this a bunch of times at this point. How are we going to do this? Well, the first thing we can do is we can group by. Again, the question is what models have an average city MPG greater than 18? Okay. So we can group by model. And again, here's what this function we already saw. Group by MPG, group by, apply that to the MPG tibble and group it by model. So we're going to assign groupings based on model. And then we're going to essentially call this new R object A. Okay. So we'll do that. And not surprisingly, it's essentially the same thing, except the same tibble, except now it's assigned groupings. Okay. And then we're going to summarize, and we're going to apply that summarize function to A, which is this group tibble. We're going to say city.mean is our new variable, and it's the mean of city. We're going to call all of this B, right? We just saw this. This should all be fairly familiar to you. And so now if we look at B, again, we've got a tibble that has these average city miles per gallon across all models. Okay, so there's 38 models total. And then the last part of that question, which is has an average MPG greater than 18. And so here we can go through and count 1, 1, 1, 1, but or we can also filter. And so here we're filtering. We're going to apply that filter to your output C, which is a tibble that's got the summarized data. And then we're going to require our conditional statement is city mean has got to be greater than 18 MPG. Okay, so we can run that. And then here's your answer. There's 16 total observations. What models have an average city MPG greater than 18? This is your answer right here. Okay, so that essentially took 3 steps. The problem is that, you know, are we really concerned about creating an R object A and really concerned about creating an additional R object B, these kind of intermediary steps? Well, not really, right? We don't need to take up memory by doing that. So the above code works fine, and it's perfectly fine, but it requires that you spend more time setting up and saving intermediate output, all right? So piping allows you to bypass this. And so this is exactly what we just did up here with A, B, and C, but it's all essentially in one call, one line of code. Now, you'll say, well, there's 4 lines here, Steve, of course, but I just put, you know, carriage returns in here just to kind of help you see it a little bit better, all right? So what are we doing here? Let's talk about this piping. So piping, we're going to take MPG. Again, this is like, we can ask this question, and it just is a lot more intuitive in terms of how it successively flows. So we're going to take MPG. We're going to group by model. After we do that, so we know there's 38 models. After we do that, we're going to summarize. We're going to say city equals city.mean equals the mean of the city miles per gallon. And then again, finally, we're going to filter by city mean is greater than 18. Okay. So again, this piece right here is all the same components as this, except you don't have to spend time saving output and kind of doing these intermediary steps. And it just is like this, then this, then this. You can kind of think of it as a cascade of events. And we get the exact same output as we did when we asked for C and did it A, B, and C, okay? So another example, which drivetrain has, or the DRV variable has the best highway miles per gallon? So here we're gonna take, you know, we can take our DF data frame, or MPG data frame, doesn't really matter. Let's just take MPG to keep things consistent. We're going to group by DRV. And of course, we can do this, right? We can just run this one step at a time, like this. And here's our group tibble, right? By drivetrain, three three groups of drivetrain: front wheel, rear wheel, and four-wheel drive. But if we run the whole line of code, and then we're going to summarize it, we're going to call highway.max is the max of highway. All right. So again, the question is, which drivetrain has the best highway MPG? And so maybe this isn't the best worded question or most interesting or whatever, but what has the best MPG for each of the three classes of drivetrain or whatever it might be? So here they are. Okay. There's 28 for MPG for four-wheel drive, for front-wheel drive 44, and for rear-wheel 26. Okay, so you can use piping, and the beauty of piping, okay, so it's not just about dplyr, but you can use this really for any package in tidyverse. So we'll talk about graphing and ggplot next week, but you can do these sorts of manipulations and send it straight to a graph. Instead of printing output in your console, it can actually generate graphs. Use it for tidy for data manipulation, tidyr for tidying data. You know, the whole tidyverse ecosystem or the universe or whatever you want to call it, all is amenable to piping. So it really helps just kind of, again, this class is about getting you efficient, familiar, and up to speed with R, just gaining a sense of comfort. And piping is one of these things that really helps kind of move in this direction, okay? So let's just take it a little bit further here and just imagine some maybe a little bit more realistic scenarios, okay? So here's a question. Is there a correlation between city and highway MPG between manufacturers? In other words, within any given manufacturer, what's the correlation between city and highway MPG? This is, I don't know if it's an interesting question, but it's, you know, we would assume that for any given manufacturer, if your city, if for in a model, if, you know, one of your models is as your city miles per gallon increased or decreased, your highway miles per gallon would do so the same, okay? So again, we're going to take our MPG data set. We're going to group it by manufacturer, and then we're going to summarize it. And we're going to call our output correlation. So that's the name of the new variable. We're going to apply this function core. And I don't think we've experienced this, maybe we have, but core is, you can look, it's just in base R, and it's essentially runs a correlation analysis on two vectors. That's what it does, okay? So we're asking for a core between city and highway, and we're calling it correlation. So this is, again, this is a function that's running on both, not just a single variable, but on city and highway concurrently, right? So here's the call. And here we can see, for the most part, there's pretty high agreement between when a car manufacturer, the highway and the city miles per gallon in a car manufacturer. Interestingly, Mercury is the only negative value here, and I'm not sure what's going on with that. We could look at that, but you know, maybe that's a typo or some reason for some sort of outlier. I'm not entirely sure. Okay. And of course we can use, you know, what about, so here's like the same question with manufacturer. What about for every model and manufacturer? So here it's really the same call, but we're going to put in, instead of just grouping by manufacturer, we're going to group by model manufacturer. And so here it's a tibble. There's 28 more rows. So we can also use this print n equals infinity. It was basically kind of overrides this tibble truncation thing. That's oftentimes why I've been coercing things into data frames, just to get around this. I think kind of find it a little annoying personally, but here is print. The number to print is infinity. So when we run this, it prints all of the output, okay? So again, it's not just for each manufacturer and model, okay? So I don't know if that's an interesting question. It's not terribly interesting to me, but maybe other people would like that. All right, so piping, there's a lot of things we can do with it, and you can think about it, again, in the context of anything that we do in tidyverse, okay? So it's a really nice tool to be aware of and just start thinking about using.